All right, welcome to our masterclass on one of the most amazing pieces of engineering you'll ever find, your circulatory system. It is literally your body's personal transport network, and we're about to give you the complete roadmap.
I mean, just stop and think about that for a second. 60,000 miles. If you stretched out all of your blood vessels, they'd wrap around the entire planet, more than twice. It is a massive, non-stop highway working every single second to keep you going. And today, we're going to give you the map to it all.
So here's our game plan. First, we'll look at the roads themselves, the three types of blood vessels. Then, we'll pop the hood on the central engine, your heart. After that, we'll follow the full journey of blood through the system. And finally, we're going to see how you can actually supercharge this whole network with exercise.
Okay, first up, let's talk about the infrastructure. You see, just like a real highway system, your body has different kinds of roads for different jobs. You've got your massive freeways, your smaller roads, and then your tiny little neighborhood streets. These are your arteries, veins, and capillaries.
Now, before we get into the nitty-gritty, here's the absolute simplest way to remember the big two. Arteries carry blood away from the heart. See, A for away. Veins bring it all back towards the heart. Get that down and you're already halfway there.
Okay, so check this out. It all makes perfect sense when you see how the design of each vessel perfectly fits its job. Arteries? They need thick, strong, muscular walls because they're handling that high-pressure blast of blood coming straight from the heart. Veins, on the other hand, are dealing with low-pressure blood, so their walls can be thinner and the space inside, the lumen, is wider. And then you've got the capillaries, which are a whole different ballgame.
Right, so imagine the sheer force of every heartbeat. Bam! That's why the artery wall has to be so tough and elastic. It needs to stretch with that powerful push and then squeeze back to keep the blood moving along. It's basically a high-pressure superpipe built for power. Now, here's the problem for veins. The pressure is way lower, so there's a real danger of blood flowing backward, especially when it's trying to get from your feet back up to your heart. I mean, gravity is not your friend here. So, what's the brilliant solution? These awesome little one-way valves. They swing open to let blood pass through on its way up, and then they snap shut to make sure it can't slip back down. Pretty clever, huh?
This is where the real action happens. We're talking about vessels so ridiculously narrow that red blood cells have to queue up and go through in single file. And their walls? They are just one single cell thick. That design makes them the absolute perfect place for the great exchange, dropping off all the good stuff like oxygen to your cells and picking up the waste products like carbon dioxide.
So, we've explored all the roadways. Now, let's head to the central station that powers this whole operation. All those roads lead to and from the incredible engine that drives everything, the heart. And trust me, it's not just a simple pump. It's a seriously sophisticated four-chambered powerhouse.
And here it is. The first thing you'll probably notice is that it's clearly divided into a right side and a left side, with two rooms or chambers on each side. So let's break down what each of these parts actually does.
Let's start right at the top. These two upper chambers are called the atria. You can pretty much think of them as the heart's waiting rooms or lobbies. This is where blood arrives. The right atrium collects all the used, deoxygenated blood from the body, while the left atrium collects that fresh, oxygenated blood coming back from the lungs. Now, right below those waiting rooms are the real power chambers, the ventricles. If the atria are the lobbies, these are the launch pads. You can see how much thicker their walls are, and that's because they do the really hard work of pumping blood out of the heart with serious force. The right one sends blood on a short trip to the lungs, while the left one has the massive job of pumping it to your entire body.
So this is probably the most important thing to get. The heart is really two pumps working side by side. The right side, we always show it in blue, handles all the deoxygenated blood. Its job is to pump that blood over to the lungs for a pit stop to get more oxygen. Then the left side, shown in red, gets that fresh, oxygen-rich blood and pumps it out with incredible force to every single part of your body.
Okay, we know the roads and we know the engine, so now let's actually follow a single, lonely red blood cell on its incredible, continuous journey. It's this amazing figure-8 loop that never, ever stops.
All right, let's follow the flow. First, that used deoxygenated blood comes back from the body and enters the right atrium. Then it drops down into the right ventricle. From there, whoosh, it's pumped out through the pulmonary arteries straight to the lungs. In the lungs, it drops off its carbon dioxide and picks up a fresh tank of oxygen. Now it's bright red and oxygen-rich, and it heads back to the heart's left atrium before dropping down into the super powerful left ventricle. And finally, bam,
It's blasted out through the aorta, the body's biggest artery, to deliver oxygen everywhere, from your brain to your toes. And then the whole cycle starts all over again.
Okay, so that's the system. It's amazing. But how can we measure how well it's working? And, more importantly, can we actually make it better? The answer is absolutely yes. And that brings us to the link between your circulatory system and your fitness.
Believe it or not, the performance of your heart, this incredibly complex organ, can be boiled down to one beautifully simple equation. This right here is the key to understanding your cardiac output.
So let's quickly break down what these letters mean. Q, or cardiac output, is the big number. It's the total amount of blood your heart pumps out in a whole minute. And it's figured out by multiplying two things. First is SV, or stroke volume. That's the amount of oomph in each beat, how much blood gets pushed out with a single pump. And you multiply that by HR, which is just your heart rate, or your pulse, plain and simple.
So how do you hack this formula to your advantage? Well, just like any other muscle in your body, when you exercise your heart regularly, it gets bigger and stronger. There's a fancy term for it, cardiac hypertrophy, but the idea is simple. You work out a muscle, it adapts, it gets stronger, your heart is no different. And look at the incredible difference this makes. An athlete's heart is a high-performance engine. Because it's stronger, it can pump way more blood with every single beat. That means a much higher stroke volume. And because each beat is so powerful and efficient, the heart doesn't have to beat as often when you're just resting. That's why a low resting heart rate is such a classic sign of being fit.
And really, that's the key takeaway. It all comes down to efficiency. A trained heart is a more efficient heart. It can do the exact same job with way less effort. This not only helps you perform better when you need it, but it also means less wear and tear on your entire system over the course of your life. It's just working smarter, not harder.
It's a pretty powerful idea when you think about it. Your body is literally designed to adapt and improve based on what you ask it to do. The heart is an incredible example of that, but it does make you wonder, doesn't it? What else is possible? Hey, if you want to put all this new knowledge to the test and really make sure it sticks, head on over to revisedirect.com and grab our free heart labeling worksheet. It's a fantastic way to lock in everything we've talked about today. Thanks so much for watching.